The division here is holoblastic. Why we call it as holoblastic? We said it as holoblastic because the whole zygote is dividing. How does it is possible? Because that egg of human being is microlecithal egg. Hence, the whole zygote can divide. We call it as holoblastic cleavage. Then, being belongs to the deuterostomia, radial cleavage can be expected. Indeterminate cleavage can be expected. Then, radial, holoblastic, microlethal, and equal cleavage because the blastomeres formed here are equal in size. In the way, the zygote starts the division and will become 2 cell and then 4 cell. Likewise, 8, 16, 32 cell stage, we said it as marula. We called it as marula. In the marula, our said event that compaction occurs here, that compaction results outer trophoblast cells are tightly bind each other with tight junction, and inner the cells which are loosely aggregated over, we called them as the which connected each other by gap junctions that are leaving some space for the flow of nutrient. We call it as formative cells or inner cell mass. Trophoblast cells outside, formative cells, inner cell that formative cells or inner cell mass inside. Okay, this is the story we already learned earlier than in the previous class. So that's why I'm going a little faster here. The stage we call marula, and in the marula, the compaction occurs. Okay, and soon you can see a cavity is appearing here. There you can see a cavity is appearing. Appearance of the cavity is called cavitation. The total scenario is happening in the fallopian tube where now it is going to drop into the uterine cavity. So whenever it drops in the uterine cavity, the uterine fluid enters through this cavity, then the marula will turn into a next stage, what do you call blastocyst. The stage we say blastocyst. The formative cells or inner cell mass are lifted up. Okay, so the like this formative cell, inner cell mass, and outer trophoblast or trophectoderm and inner cell mass. So at this time that enter the uterus, now it is going for preparation of the implantation process. For implantation process. So for that we need to know about the uterus with 3 layers: epimetrium, middle muscle layer called myometrium, and the uterus is ready with endometrium layers because of progesterone hormone released from the corpus luteum. So these are the endometrium layers. Okay. So then our said blastocyst, the so-called blastocyst is here and trying to, the trophoblast cells are trying to enter that by, that in the mean period you need to understand that zona pellucida which is around this is disappeared. At this time it is disappeared. Just before the implantation, zona pellucida is disappeared and the trophoblast by proteolytic enzymes started penetrating, entering into the endometrium layers of mother. At the time, you can see the trophoblast is with two types of layer, which is penetrating inside is called syncytial trophoblast, and that remaining that with cell membranes in between, we call it as cytotrophoblast. The syncytial trophoblast entering inside. So, what is the final scenario here? That finally the endometrium layers completely surrounds the blastocyst. Completely surrounds the blastocyst. That we have to show here. That after the implantation, when fully completed, that endometrium, that embryo much penetrated into the endometrium layers, and so what happens that fully penetrated like this, that is fully penetrated. So after the implantation, that the endometrium layer is called as decidua. We named the decidua. The decidua basalis, decidua capsularis, and decidua parietalis. Other than the site of implantation, that the endometrium layer is termed as decidua parietalis. Then between the embryo and the lumen of uterus, this is the decidua. That this is the lumen of uterus, this is the embryo. So between the embryo and the lumen of uterus, that whatever present, that is called decidua capsularis. And the very important where the nourishment is going to happen, nourishment transfer of nutrients is going to happen, that is called decidua basalis. Okay, so this is the implantation process. After that, we said that the embryo will become disc-like and much expanded. We call it as discoblastula. And here, delamination occurs, which results the formation of two layers, that epiblast and hypoblast layers are getting formed here. Epiblast and hypoblast. So then after that hypoblast layers, some of them will separate and will move towards the blastocele cavity, that with that line below the trophectoderm, which their surface will face the cavity. So that line below the trophectoderm. Okay, so this is called actually yolk sac. That we have a separate explanation for extra embryonic membrane. Okay, so these two are called extra embryonic membrane. This green is going to form the embryo proper. That means the total fetus is going to form from this green. What is this? This is epiblast. This clarity is required over. We need to follow the fetus, the baby. Who is going to be the baby? Okay, so green is going to form the baby. That means epiblast cell. What about the remaining one? They don't form baby? No, they don't form baby. They form connection with the baby and mother. Okay, that what you call placenta, extra embryonic membrane. If you understand this fact, you will understand everything in the textbook also. Okay, so then after the process, that epiblast and hypoblast, now what you are saying, let me take the green. That means need to go with the epiblast. Epiblast cells will grow in one direction and they're going to form a primitive streak, primitive groove, primitive knot, primitive pit. Then below that, what you can see, the below that you can see the hypoblast cells are present here. Hypoblast cells are present. So ingression of epiblast cells, ingression of epiblast cells, as we shown the video in the previous class even, the ingression of epiblast cells replace the hypoblast cells for the formation of endoderm. That means epiblast cells are only going to form the endoderm. The future mesodermal cells converge towards the primitive groove and reaches between epiblast and endoderm and migrate in all directions that form the mesoderm. So whatever that still we have that layer, trophoblast is there and all that we have to discuss in the form of extra embryonic. So now we are going in the center of embryo. That epiblast is there. Now termed as ectoderm after the formation of mesoderm and endoderm, you can call it as ectoderm. So the three embryonic germ layers is formed. We call it as trilaminar embryonic disc. So these three are going to form the baby. That we need to understand. These three are going to form the baby. Okay. In the mean process, we discussed earlier about the induction process also. That means the mesoderm, which is formed here, going to develop notochord. Development of the notochord in the mesoderm induces the ectodermal cells of epiblast area, this area, that induces the neural plate to form. So that means why? Because that coordinated development is required over in the body, that as I proved earlier in the class. So then that development of the mesoderm, that notochord in the carda mesoderm from the mesodermal layers, that induces the neural plate. So that means at a time neural plate formation as well as notochord formation, the replacement in the form of vertebral column and skull, and here the development of brain and spinal cord will go happen. That means one organ interlinked with the another organ. So that's what you call induction. Formation of this notochord stimulate the formation of brain. That means future brain, neural plate formation. So that means one organ development initiates the other organ development. We called it as induction. Okay, so if you want to make this definition complicated, we can make it. One unspecialized tissue into the specialized tissue induces the another unspecialized tissue into the specialized tissue. We call induction. What is the meaning of unspecialized Ectoderm, mesoderm, endoderm. They are unspecialized. Some of the mesodermal cells are formed notochord. What is this? Specialized. Organ is formed. That's why what we call specialized. They induce another unspecialized tissue. That means ectoderm to neural plate. That means specialized. So that's what we can say. Formation of unspecialized tissue into a specialized stimulates another unspecialized tissue into specialized. We call it as induction process. So we are seen in the previous class up to there, and now we go with these ectoderm and endoderm and mesoderm. Okay, so that further I let me introduce back again. This is the ectoderm. So below the ectoderm, what is expected over the mesoderm is there. I'm giving little gap between the cells that we will be able to understand this area easily. So this is endoderm. Okay. So some of the issues are explained. That means some of the issues. What I'm saying, some of the issues totally is not explained. 9 months of development is not at all explained. We have some jumpings in between. Just landmarks and milestones only we are looking forward. We are not doing gynecology now. We are just moving a brief information of this embryonic development. Okay. That means it may take 9 months to see the 9 months of development. Okay, so that's why we are just giving brief. Then that means we are jumping here. From here, we are going to say how the organs are going to form directly. So, intra-embryonic mesoderm spreads in all direction between the outer ectoderm and endoderm. That intra-embryonic mesoderm. That means you need to think here. Spread in all direction between the outer ectoderm and inner endoderm. The longitudinal column of the mesoderm adjacent to the notochord. That means here itself, notochord is formed, isn't it? The longitudinal column of mesoderm adjacent to the notochord and neural tube. Neural tube means here in ectoderm. Adjacent to the notochord and neural tube on either side is called epimere. I am making box for epimere. This is epimere. Okay. So the mesoderm around the gut, that means here, nearly here in this area, gut is going to be formed. So mesoderm around the gut is called mesomere. The mesoderm, hypomere. The mesoderm in between these two is called as mesomere. So now let me label epimere. Address, complicated address they are given actually. Now simply we can say here that mesoderm is now differentiated into three portions. Epimere, mesomere, hypomere. But how they are given address? Where notochord and neural plate are present, that part is epimere. Where gut is going to be formed, gut means that we need to look toward the endoderm, because that you should know that is the gut is formed from endoderm. There, that hypomere is present. Between the epimere and mesomere, that what is epimere and hypomere, we will find mesomere. Okay, so the address is given. Next, they have some names also. Epimere is also called paraxial mesoderm. Then hypomere is called lateral plate mesoderm, and mesomere is called intermediate mesoderm. So this paragraph is fully explaining about only on mesoderm. You remember this is ectoderm and this is endoderm. So now we are talking here only. Ectoderm, endoderm, mesoderm. So we are talking about mesoderm only. So that's why let me focus on mesoderm, only drawing mesoderm. So that address is over. That's why I'm taking a little bit freedom to show all this in a box like epimere, then mesomere, then hypomere. So just showing mesoderm. Epimere is also called paraxial mesoderm, and hypomere is also called lateral plate mesoderm, and mesomere is also called intermediate mesoderm. The epimere become a segmented into that cubical blacks called somites or metameres. Again division, that somites are called metameres. Okay, so the epimere become segmented into cubical blacks called somites or metameres. So what are they? Sclerotome, myotome, dermatome. I'm not writing the total, I'm showing here like this. Sclerotome, myotome, dermatome. Now your work started. You need to remember sclerotome form, vertebral column, myotome form, voluntary muscles of the body, dermatome form, dermis of the skin and other connective tissues. This is the thing that examination material. That means question can be converted here. Question can be asked here like this. So this is the area you have to remember. So epimere is differentiated into three somites again. What are the three somites? That sclerotome, myotome, dermatome. This is sclerotome, this is myotome, and this is dermatome. Sclerotome form vertebrae, then myotome form skeletal muscle, and dermatome form skin and connective tissues. Okay. Then now talking about this area, mesomere. Mesomere form. Mesomere forms the urinogenital organs and their ducts. Mesomere form the urinogenital organs and their ducts. Next, this area, hypomere. The hypomere splits into outer somatic and inner splanchnic mesoderm. Somatic and splanchnic mesoderm means that you can understand. That is coelom. Wherever you use this word, somatic and splanchnic, that somatic and splanchnic. That means that is coelom. So this coelom is there in the embryo. That's why we call it as intra-embryonic coelom. We say it as intra-embryonic coelom. So in this paragraph, you need to remember who is going to form whom. That's all. Okay. Intra-embryonic coelom is formed between these two layers and it gives rise to pericardial pleural peritoneal cavities. This is just giving address and who is going to form whom. That's what I said about jumping, that we just jumped off. Okay. So then let me say once again. In the mesoderm, there are three parts. We made it already. Epimere, mesomere, hypomere. Epimere, mesomere, hypomere. Okay, so let me show you. This is epimere, this is mesomere, and this is hypomere. Okay, so epimere again differentiated into three: myotome, sclerotome, dermatome. So in that myotome, sclerotome, dermatome. Now myotome form, sclerotome form, dermatome form, mesomeres form, then hypomere form. These are the five things to be remembered in this paragraph. Myotome form the skeletal muscle, voluntary muscles of the body. Then sclerotome form vertebrae, vertebral column. Dermatome form skin and connective tissues. Next, mesomere form urinogenital organs and their ducts. Hypomere form outer inner embryonic coelom, which includes somatic and splanchnic mesodermal layers, which leads to the formation of pericardial pleural peritoneal cavities. How they form and then what are the sequential divisions, nothing matter for it, just the form. You need to understand. Okay, so just let's move on to the extra embryonic membrane. So that means in the mean period of time, you have to understand that will go on for the development. Ectoderm and mesoderm, endoderm, they pay their effort to form digestive, respiratory, circulatory, excretory tissues. So you should understand in that particular format. Okay. Then next we'll go with extra embryonic membranes. So need in one frame. So let me show you. No. We need little enlarge. So first of all, let me show you what is extra embryonic membrane, their location. Then after, let us see how it is in text. A little size need to be increased. Yeah. And I think we can reduce this size. So be patient. This is a little complicated. I am trying to make it one frame, that's all. I am trying to show everything in one frame. Yeah. So that first of all, extra embryonic membrane. First of all, let us bring our participants. So that ectoderm is there ready, and the below that mesoderm is there ready. That here only we discussed about epimesoderm and hypomeres. And the next one more hypomere, that is ready. Okay. So who are the remaining leftover? Their streak, groove, which you may recognize. Okay. So who are the remaining one? The remaining and very important one, that is trophectoderm, which we are following from the beginning, isn't it? The trophectoderm. Now the role of trophectoderm that you can understand. Trophectoderm. Then who is one more left over? That is that blast cells. Some still remain here. They are replaced here actually, but here only they are present, isn't it? So this is the full embryo. That till the time this we are taken these three only. So now the full embryo we are talking about. Then now let's start. Development of fetal or extra embryonic membrane helps protect the embryo from desiccation, mechanical shock, absorption of nutrients, exchange of gases. The importance of extra embryonic membrane is they protect the embryo from desiccation, mechanical shock, absorption of nutrient, exchange of gases. The epi blast adjacent to the trophoblast, that address we have to take it out. Epi blast adjacent to the trophoblast. So pointing out that area. This is the area. Epi blast adjacent to the trophoblast. Okay, so I'll point with another color. No, red will take over. So this area. That epi blast adjacent to the trophoblast migrates away from the trophoblast, forming the amniotic cavity. So we got it. Amniotic cavity. This is amnion. Okay, so amnion. Next, the formation of amnion and chorion in human embryos is different from that of other amniotes. No problem. We don't know in other amniotes how it is happening. Isn't it? Leave it. The lining of the amniotic cavity is made up of cells called amnioblast cell. The lining of amniotic cavity is made up of the cells called amnioblast cells, derived from where they get derived. They are derived from epiblast only, derived from the epiblast cells. The amnion is filled with water. Here it is, the water, amniotic fluid. Okay, so let me jump the label. The amniotic fluid. Okay, so the story of amnion is over. The story of amnion is over. Let me say once again. Epiblast adjacent to the trophoblast migrates away from the trophoblast, forming the amniotic cavity. The lining of the amniotic cavity made of cells called amnioblast derived from epiblast. Okay, so that's it. The story is over. Now, next, the amnion is filled with water. Will end. The hypoblast is pushed down, already pushed down, we have seen earlier. The hypoblast is pushed down, forming the lining of a cavity called yolk sac. So that we have seen this earlier. Okay, so that yolk sac already shown to you. That yolk sac, cavity called yolk sac. Now, the chorion consists of an outer layer formed by the primitive ectoderm or trophoblast and inner by the somatic mesoderm or extra embryonic mesoderm form which the chorionic cavity is formed. It is difficult actually, that lines doesn't represent the issue. The chorion consists, I'll give the conclusion in the end again. The chorion consists of an outer layer formed by the primitive ectoderm. Here it is, we have to talk about again. The primitive ectoderm. So that this area, that form primitive ectoderm and inner lining by the somatic mesoderm form the chorionic cavity is formed. The chorion undergo rapid proliferation of the cells and form chorionic villi that we already see in endometrium layers by proteolytic enzymes. The chorionic layer that we said syncytio trophoblast, isn't it? That is nothing but chorionic villi. That you need to understand. Okay. Then the chorion undergoes rapid proliferation of the cells and form chorionic villi. The chorionic villi invaded the endometrium and help in the transfer of nutrients and oxygen from the maternal blood to the fetal blood. Okay. The chorion surrounds the embryo and other membranes. So soon that the chorion surrounds the embryo and other membranes also. That means that in the developmental process, The chorion is going to surround other membranes also. Soon, a fourth membrane, that is allantois, is getting formed. The allantois develops as an outgrowth from the embryonic hindgut, splanchnoplure, consisting of outer outer mesodermal layer and inner endoderm. So further I will give the conclusion. The membrane of the allantois meets the inner surface. Slowly it meets the inner surface of chorion. So I should use black here to understand much better. This is the allantois. Soon it meets with the chorion. Okay, so that form choreo-allantoic placenta. That form choreo-allantoic placenta. That means in case of human being, chorion withdraw the nourishment, allantoin supply the excretory wastage. So the placenta facilitates a more effective and efficient placenta facilitates a more effective and efficient path for exchange and passage of nutrients and respiratory gases, hormones, antibodies, it is, etc. Between the fetus and mother, by the 12th week of pregnancy, that all it is getting formed here. So I'll give the conclusion for this intra-embryonic coelom we discussed earlier. So that links are missing actually in this area. You should understand we are missing some links. That means we are trying to explain this area in brief. That's why we are missing some links. So that's why I'll give the final conclusion here. Somatoplure, splanchnoplure. So that somatoplure and splanchnoplure. So there are two actually, somatoplure and splanchnoplure. Somatoplure somatoplure include trophectoderm plus somatic mesoderm. Trophectoderm plus somatic mesoderm. Splanchnoplure include that visceral mesoderm or splanchnic mesoderm. It includes splanchnic or visceral mesoderm, splanchnic mesoderm plus extraembryonic endoderm, extraembryonic endoderm. Okay, this is the total story actually. So from here, that our said extraembryonic membranes are present. In the paragraph, some is given, some is not given. So that's why I am showing here the final conclusion. Amnion and chorion are developed from somatoplure and yolk sac allantois. These two developed from splanchnoplure. What all these are? What all these are? These are all extra-embryonic membrane. That means extra-embryonic, embryonic. When you talk about embryonic coelom, we discussed earlier in the embryo. Extra-embryonic coelom outside the embryo. That means we have trophectoderm and we have ectoderm also. That difference you need to find out. We have a trophectoderm and we have ectoderm also where the neural plate is going to be formed. We have mesoderm and we have extraembryonic mesoderm also. Mesoderm we discussed now, epimere, mesomere, hypomere. Just understand this is double action. Embryonic layer, extraembryonic layer. Okay, this is the final conclusion. Somatoplure, splanchnoplure. Somatoplure include trophectoderm plus somatic mesoderm, which leads to amnion and chorion. This kind of differentiation why I am giving here, we got question from here. Straight away, straight question from here. Somatoplure include, splanchnoplure include. We got question here. Somatoplure include trophectoderm, somatic mesoderm. What it form? Amnion and chorion. Yolk sac and allantois are formed from that allantois is formed from endoderm and yolk sac is formed from that the splanchnic mesoderm. So that what we are talking about. We are not going for that itself. This is a debatable issue. That means nearly 2 hours it will take over to explain exact criteria of the extraembryonic membrane. So I am giving up to intermediate level. If you remember this particular page, that will be enough for us. Okay, some of these are mentioned in the text here. Some of these are mentioned. Okay, so if you want to take the screenshot, I'll allow you once again to you. So this is the area. This is the area to be remembered. That there are four extra embryonic membranes: amnion, chorion, yolk sac, allantois. Amnion and chorion developed from somatofluor. Yolk sac and allantois developed from planktonofluor. Okay, so that only we are showing actually in the diagram, that we are trying to show that particular thing only, somatofluor and planktonofluor. In the previous diagram, in the earlier diagram, that when we see that some of the issues we can see, that means with the available information which we learned till the time, with that you can see this, you see this. Yes, so in the diagram, that yolk sac, this is yolk sac. So that what I am saying here, these are the extra embryonic membranes. Then this is allantois. Okay, so these are all formed from. Where is the embryo? I'll make a box to the embryo. This is the embryo. Okay, so is it clear to see? Visibility there? Yeah, this is the embryo in the yellow box. Remaining all are extra. So that's what we are discussing. So finally, that how do we have connection with the mother? So that straight away that connection I will show you. That endometrium layers. Endometrium we are doing always with, right? Endometrium layer. So with that I'll make a hypothetical diagram. This is the embryo. I'm drawing little distant to understand. This is the embryo, and we said that surrounding the embryo, amnion is there, and chorionic villi is penetrating into the mother, and soon allantois is also going to participate with this. Allantois is developed here. So the from the mother withdrawn of nourishment is possible by chorion, and excretory materials are given by allantois. So that's why our placenta can be called as choreo-allantoic placenta. Choreo-allantoic placenta. Just to understand, our placenta is choreo-allantoic placenta. The remaining yolk sac is no way useful for us. For example, if you go to the birds, in case of birds, yolk sac is filled with yolk, and there is no these kind of connections, isn't it? Will form a calcium carbonate egg shell surround, will form a calcium carbonate egg shell surround, and will leave this to the outside, isn't it? So at the time we say that placenta is called yolk sac placenta. So know that, but ours is, we are drawing nourishment from the mother with the help of chorion. We are that excretory materials to the mother is given by allantois. So that's why our placenta is called choreo-allantoic placenta. Okay. So the final conclusion I am giving here for these, whatever we learned about the extra embryonic membrane, development of the fetal or extra embryonic membrane help to protect the embryo from desiccation, mechanical shock. That means that is by amnion, absorption of nutrients, exchange of gases, possible by chorion. Epi blast adjacent to the trophoblast migrates away from the trophoblast, forming the amniotic cavity. The formation of amnion and chorion in human embryos is different from that of other amniotes. The lining of the amniotic cavity is made up of cells called amnioblasts derived from Epi blast. The amnion is filled with water, amniotic fluid. The hypoblast is pushed down, forming the lining of a cavity called yolk sac. But yolk sac don't have any value for us. The chorion consists of an outer layer formed by the primitive ectoderm or trophoblast, and inner by somatic mesoderm or extra embryonic mesoderm, from which the chorionic cavity is formed. The chorion undergoes rapid proliferation of the cells and form chorionic villi. That is called implantation, we discussed earlier. The chorionic villi invade the endometrium and help the transfer of nutrients and oxygen from the maternal blood to fetal blood. The chorion surrounds the embryo and other membranes. Soon a fourth membrane called allantois will develop as an outgrowth from the embryonic hindgut, the splanchnopleur. That means that only I expanded now. The splanchnopleur consisting of outer mesodermal layer and inner endoderm. That means that area fully I explained over. The membrane of the allantois meets the inner surface of the chorion and form highly vascularized region called allantochorion. Allantochorion contribute the fetal part of the placenta. So if somebody asks what is your placenta, so we have to answer human placenta is chorioallantoid. The placenta facilitates a more effective and efficient path for exchange, a passage of nutrients and respiratory gases, hormones, antibodies, etc. Between the fetus and mother, there is by the 12th week of pregnancy. Organogenesis, during organogenesis, regions of three embryonic germ layers develop into rudiments of organ. That means that is a final statement we are given. That means ectoderm, endoderm, mesoderm will take care of everything. Embryonic ectoderm, embryonic mesoderm, and embryonic endoderm. That they will take care of everything. Let's take a look on the placenta. The placenta consists of two essential portions: maternal part and fetal portion. Okay, so this is as usual epimetrium or perimetrium, and middle muscle layer with that myometrium, and innermost endometrium layers. This is mother uterus. So talking about the fetus, so fetus side we said that chorionic villi is coming. Villi will take with green color, that you can understand. Okay, so I'll put a box in between. There you can understand whom we call placenta. This is called placenta. In the placenta, one is from mother side, maternal part of the placenta. That means endometrium. From other is baby side, fetal side. So fetal side, who is participating? Chorion is participating. Now you read, you can understand that the placenta consists of two essential portions. Maternal part of the placenta derived from the endometrium of uterus, and fetal membranes of the fetal part of the placenta. Maternal components. Who are the maternal components of the placenta? Uterine epithelium, uterine connective tissue, and uterine capillary endothelium. Everything in that uterus part. That means endometrial part. Endometrial epithelium, endometrial connective tissue, endometrial blood capillaries. Okay. Fetal components. Fetal components nothing but chorion, chorionic villi, the fetal capillary endothelium, fetal connective tissue, fetal chorionic epithelium. This is from the baby side. Okay. So fetal components of the placenta: fetal capillary endothelium, fetal connective tissue, fetal chorionic epithelium. From mother side, uterine epithelium, uterine connective tissue, uterine capillary endothelium. Simply what I said, from mother side, endometrial layers. From baby side, that chorionic layers. Okay. The inner region of the chorionic villi develops a network of capillaries of the umbilical cord, and that form the umbilical artery and umbilical vein. That chorionic villi soon. That means initially when we are seen in the implantation, we called their sites syncytiotropoblast, cytotrophoblast, like that. That won't stop there. That will go on as long as embryo is growing. That chorionic villi, chorionic blood capillaries, that all they are going to be formed here. Okay. So in the series, what we said, there are two: umbilical artery, umbilical vein. We'll draw the fresh one. That epimetrium, myometrium, endometrium. Here in national examinations, you'll find some interesting questions here. I'll draw that. Just imagine, this is the embryo. Just imagine. Umbilical artery, umbilical vein. We need to understand that chorionic villi is going to form umbilical artery and umbilical vein. Okay, so that UA, UV. So what are their roles? They are doing the reverse role. That you need to understand. The placenta of human is called, the inner region of the chorionic the villi develops a network of capillaries of the umbilical artery and umbilical vein. These vessels run in the tough umbilical cord. That tough umbilical cord, that means so slowly the placenta is becoming much tightened, that to become the tough umbilical cord. So now my view here, arteries, what is the function of artery? Arteries are in supply, isn't it? So that means you should show the direction like this. So veins are in collection, isn't it? So listen carefully. So various kinds of national pattern, mostly in Allen, group, you'll find these kind of questions here. That there in their test will find these kind of questions. Okay, so umbilical artery. Umbilical artery supplies to whom? Mother, isn't it? And umbilical vein collects from whom? From mother. Okay, so when you are collecting from mother, what do you get? You get everything. You get oxygen, you get nutrients. Okay, then when you are supplying to the mother, what you are giving? You don't give anything to the mother. Not during development, after the development also, isn't it? Okay, so during the development itself, you are not giving anything. If you are giving anything, that you are giving carbon dioxide, whatever formed in your embryonic development. You are giving anything, that means you are giving metabolic wastes to the mother. That means the umbilical artery is rich with metabolic wastes, excretory waste materials, isn't it? Then umbilical vein, which is coming from the mother, that with rich with oxygen and nutrients, hormones, vitamin, whatever mother, whatever it is, that supplies to the baby. So that means that you need to understand that difference. Umbilical artery is having metabolic wastes because it is going towards the mother. Coming from the mother, that is the interesting thing. That contain more oxygen. Umbilical vein contain more oxygen because umbilical vein is coming towards the embryo. So keep this thing in mind. Remember this thing in mind. So when this kind of question will come, that not from embryonic development. It's a general question, isn't it? It may be if you are asking about oxygen, that will be from digestive respiratory system. If they are asking about the nutrients, that will be from digestive system. You may feel so, but logic is here. Simply you need to understand umbilical artery is from embryo to mother. Umbilical vein from mother to mother. Mother means here uterine endometrium layers. Okay, now let me continue. The placenta of humans is called chorioallantoic placenta, as allantois also fuse with the chorion in the process of vascularization. And placenta is described as hemochorial. Why it is hemochorial, we can say that because the maternal blood comes in contact into direct contact with the membranes of the fetal chorionic villi. That means uterine endometrial layers. So just now only blood capillaries I am drawing. This is the condition. The red is uterine endometrial, that blood capillaries, uterine connective tissue, uterine blood capillaries. The blue is fetal blood capillaries. So they are present like this. That means from mother side, from the baby side. So they are going to be form a network-like structure. So that's why the placenta is described as hemochorial, as maternal blood comes in direct contact with the membrane of the fetal chorionic villi. So like this, the blue and red, hemochorial placenta. That's why when the baby comes out, that these particular connections with there between. To remember, baby is embryo. That we are talking here extra embryonic. Maybe they have their own blood capillaries. These blood capillaries are formed in extra embryonic layer. Okay, so that's why you cannot ask that kind of questions when damage occurs here. If I say, so do any baby get any damage? No, because this is embryo. From the beginning, we are maintaining this now. Embryo, extra embryo. Amnion, chorion, yolk sac, allantois are said to be extra embryo. So then at the time of parturition, that these blood capillaries need to separate. So at the time here that these blood capillaries will be ruptured out. Okay, so the rupturing of what? Extra embryonic blood capillaries. Okay, so that's why our placenta is also called deciduous placenta. Don't be confused with deciduous. So our is hemochorial, ours is deciduous, and our placenta is chorioallantoic placenta. Chorioallantoic placenta because chorion and allantois, the collect and supply the nutrients and excretory wastes respectively. Hemochorial placenta because maternal blood vessels come in contact. Maternal blood vessel comes into direct contact with the chorionic blood capillaries. Deciduous placenta. That means during parturition, these blood capillaries are going to be ruptured down. Then that what do you say? Our placenta, human placenta is called deciduous placenta. Okay, finally, that we are giving the conclusion with small issues here. The pregnancy, need to discuss about the pregnancy. Pregnancy is the intrauterine development of the embryo of fetus, also called gestation period. Okay, it's generally about, we use it to say 9 months, isn't it? 9 months means 36 weeks in general, but it is said to be 38 weeks in human uterus. Human pregnancy averages nearly 280 days, 260, 270. Likewise, so many calculations person to person even may vary. General given as 266 days, 38 weeks from fertilization of the egg, or 40 weeks from the start of the last menstrual cycle. 40 weeks from the last start of the last menstrual cycle. That means you need to understand that once a menstrual cycle occurs, 1 to 14 days. Okay, so on the 14th day, if fertilization occurs, from there even 2 weeks will be left over, isn't it? 2 weeks that is added here. 40 weeks from the start of the last menstrual cycle. Think about this, you'll understand. Not much necessary, that much applications won't come, but think about it. Finally, the functions of the placenta. The functions of the placenta. Okay, so let's take the functions of the placenta. The placenta facilitates the supply of oxygen and nutrients to the embryo. It facilitates the supply of oxygen and nutrients to the embryo, and also removal of carbon dioxide and excretory waste material produced by the embryo. They all go to umbilical cord artery, isn't it? So I'm making a little bit sliding out. That embryo, that placenta is connected to the embryo through an umbilical cord, which helps in the transport of substances to and from the embryo. To and from the embryo. Okay, that means umbilical artery and umbilical vein. Now need to focus on the hormone. Progesterone. Progesterone secreted by here. It is okay. So little blur. So for your comfort, I am doing the enlargement of this area. Yes. So the functions of the placenta. Give me some time that I can make it clear to you. Okay. Chalo. Progesterone secreted by the placenta is essential for the maintenance of pregnancy after the 4th month, when the corpus luteum degenerates. That you need to understand. That till the time who maintain progesterone, corpus luteum, secreted progesterone is maintained, but after that the placenta will take care of it. So that after the 4th month, that placenta is going to secrete the progesterone. Okay. Then estrogen, mainly estradiol. Do you remember? Theca interna is releasing estrogen. So estrogen, mainly estradiol, produced by the placenta, reach maternal blood and promote uterine growth and development of the mammary glands. Okay, so placenta secrete estrogen, placenta secrete progesterone. Next, that human chorionic gonadotropin, the another hormone, human chorionic gonadotropin, produced by the placenta, is similar in its actions to luteinizing hormone of the pituitary gland. Okay, human chorionic gonadotropin sends the message of pregnancy to the master endocrine system, so that LH is secreted to maintain the corpus luteum and prevent menstruation. Recall our menstrual cycle we said earlier. So that what we said, if fertilization doesn't occur, secondary oocyte will degenerate. Then the corpus luteum, that yellowish substance which is there in the which is present in ovary, that degenerate in the form of corpus albicans, and that who is waiting in the, okay, wait, let me show you the fallopian tube. Let me show you in the fallopian tube. So these things you know already, but I'm just making you to remember. In the fallopian tube, who is waiting? Secondary oocyte is waiting. Okay, so in the ovary, who is producing the progesterone? Corpus luteum is producing progesterone. We said in case of failure, if sperm don't comes, If sperm won't come, that secondary oocyte will degenerate. Corpus luteum will degenerate in the form of corpus albicans that we said earlier. Then if sperm comes and fertilization occurs, what happens? Sperm reach, fertilization happened, zygote is happened. So that information will go to the brain. That means the preventing that by 28th day you can see corpus luteum is no more, isn't it? 28th day, before 28 days itself, corpus luteum is no more. It's going to be regenerated in the form of corpus albicans. But in case of fertilization occurs when placenta is formed, that placenta is maintaining the corpus luteum also. So human chorionic gonadotropin sends the message of pregnancy to the master endocrine system so that LH, they are going to provide the corpus luteum maintenance and prevent the maintain corpus luteum and prevent menstruation and for further ovulation. Okay. Then gonadotropins are excreted through the maternal urine. This chorionic gonadotropin, that is a hormone property. If hormones are excess released in the body, then we don't have any storage. They'll go in the form of urine. They'll be released in the form of urine. So why specially for chorionic gonadotropin? Chorionic gonadotropins are excreted through the maternal urine, where their presence in the urine used to test to detect the pregnancy in its early stages. So that means the placenta is formed means, what you can understand placenta is formed means human chorionic gonadotropin is formed. Okay, we can't believe this progesterone because presence of progesterone not only by placenta, corpus luteum can do this activity. We can't say estrogen. Estrogen is there whether she is pregnant or not. Estrogen will be there because estrogen released by theca interna. Whether she is pregnant or not, progesterone will be there because corpus luteum is also secreting progesterone. But human chorionic gonadotropin is released only from placenta. Placenta is formed means that fetus is there. Fetus is there means she is pregnant. That you need to understand. Importance of human chorionic gonadotropin hormone. How do we recognize? That we'll discuss in ELISA. They have a test called ELISA. People will say we immediately ELISA means AIDS, but ELISA is a very frequent test for pregnancy. But simply identifying the chorionic gonadotropin hormone, we can confirm the pregnancy. Okay. Then gonadotropins are excreted through maternal urine, where their presence in urine is used as a test to detect the pregnancy in its early stages. Next, some more are there. Somatomamotropin hormone. It's better if you list out all the hormones of placenta. Somatomamotropin hormone, also called placental lactogen. Somatomamotropin, also called placental lactogen, has an anti-insulin effect. It has an anti-insulin effect on the mother, leading to increased plasma levels of the glucose and amino acids in the maternal circulation. That we say that as mother become diabetic at the time. That means anti-insulin effect. Somatomamotropin is giving anti-insulin. That means suppress the activity of mother insulin. Why? Because baby need more in the food nutrients. That means blood levels of blood glucose levels in the mother should be high. When they are high, insulin will reduce them, isn't it? So that's why there is another hormone, somatomamotropin, which is also called placental lactogen, has an anti-insulin effect on the mother, leading to increased plasma levels of the glucose and amino acids in the maternal circulation. In this way, it increases the availability of these materials to the fetus. Okay. The placenta protects the fetus from the relatively high blood pressure of the maternal circulation. Then the fetal tissue having a parental chromosomal effect. This is one more. As we said in fertilization, the sperm is with 23 chromosomes. It's not, is it not a foreign body? Yes, it's a foreign body because embryo is growing in the mother. So the foreign body. Then foreign body, what we do? We produce antibodies against them, isn't it? So that danger is also there. That means in every cell who is dividing, that contain 23 chromosomes of the father. But development is going on in mother. Okay, so that we need to focus there also. The fetal tissue having paternal chromosome, that means father chromosomal effect, acts as foreign structure, antigenic allograph, we say, to the mother who produces antibodies. Mother immune system produces antibodies, no doubt. Then that's why the fetus sustains such rejection for about 38 to 40 weeks by producing certain immunosuppressant substances. Immunosuppressant substances required to stop the production of antibodies from the mother. Okay, so that means, so for your sake, mother became partially diabetic. For your sake, mother became that susceptible for various infection, because when she use immunosuppressant, that means when immunosuppressants are reducing the mother's immunity, so what happens? She may get other infections also, isn't it? So by tolerating all the issues, the mother gives birth to the baby. So I hope after all reading this, may get more respect on your mother than. And during parturition, that various kinds of effect, that is, that means post-parturitional effects are there, pre-parturitional, that means the gestation period she is going to face various problems. Okay, so when before you say a word against your mother, think about the embryonic development. Watch the video once again. Okay, then the timetable, which is very, very, very important. This is the area we're going to get the questions in Neet. So that's why focus here that we are dividing it as trimesters. That means in 9 months is divided as three trimesters, about 3 months each. Focus here. This is the area we get questions. The first trimester is the main period of organogenesis. That means in the first 3 months, the development of the body organs. In human beings, after 1 month of the pregnancy, this is first question. After 1 month of pregnancy, okay, after 1 month of pregnancy, the embryo heart is formed. Question will come like that. Heart of the embryo is formed at first month. Okay. The first sign of growing fetus may be noticed by listening to the heart sound carefully using stethoscope. That means question will come here like this. That when can you hear the heartbeat of baby? From first month onward. That means the major event happened in the first month, that baby heart. The heartbeat is formed. The heartbeat you can hear. The first sign of growing fetus may be noticed by listening to the heart sounds carefully using a stethoscope. By the end of second month, next event, second month. So by the end of second month of pregnancy, the fetus develops limbs and digits. The fetus develops limbs and digits. Okay, so first month, second month, fifth month. The questions will come like this here, that the following event. So that by the end of second month, the fetus develops limbs and digits. By the end of 12 weeks, that means in the third month we are talking. Third month. So that first trimester is completed. Most of the major organ systems are formed. Need to make a table for this. First month, second month, and third month. First month, heartbeat. Second month, limbs and digits are formed. Third month, major organ systems are formed. Likewise. Okay. That, for example, like limbs and external genital organs are well developed in the third month. The first movements of the fetus and appearance of the hair and the head are usually observed during fifth month. So I'm showing events here: first month, second month, third month, and next is given in the text, fifth month. By the end of 24 weeks, that is sixth month, the body is covered with free fine hair, eyelids are separate, and eyelashes are formed. By the end of 9 months, there is no question here. 9 months, fetus will be fully developed, isn't it? So that means just make a math the following with this five. You'll be surprised, you'll get the same math the following in examination. So directly, most of the time. If not, one or two are asked over, that will be easier for us. Okay, so that's why don't write this. You just make math the following first of all. Okay. First month, you need to know heartbeat is formed, likewise. So that means you should be much careful in that area. First month of pregnancy, embryo heart is formed. Second month of pregnancy, limbs and digits are formed. Third month after pregnancy, the third month, major organ systems are formed like limbs and external genital organs. Then fifth month, at the end of fifth month, appearance of the hair and the head and first movements of the fetus. First movements of the fetus and appearance of the hair. Okay, sixth month onwards. That means sixth month. By the end of 6 months, body is covered with fine hair and eyelids are separate, eyelashes are formed. Make a map the following with these. Okay. So then moving on, that parturition. Childbirth begins with labor. That means pain, a series of strong rhythmic uterine contractions. When the 9 months are completed, the baby is growing inside, that uterine contractions that push the fetus and placenta of the body. They should come through the cervical canal, birth canal, isn't it? The process of delivery of the fetus is called parturition. Parturition is induced by a complex neuroendocrine mechanism. The signals for the parturition originate from the fully developed fetus and the placenta, which induce mild uterine contractions called fetal ejection reflex. Fetal ejection reflex. This triggers the release of oxytocin, the pituitary gland, neurohypophysis, hypothalamus. If you remember, hypothalamus releasing oxytocin and makes store in the pituitary gland, posterior pituitary. So from the maternal pituitary, because of fetal ejection reflex, oxytocin is released. That oxytocin acts on the uterine muscle and cause stronger uterine contraction, which in turn stimulate the further secretion of oxytocin. That as long as it's going on, that stimulates the secretion of oxytocin. The stimulatory reflex between the uterine contractions and oxytocin secretes the continues, resulting in increasing the stronger contractions. This leads an expulsion of the baby. In the mean period of time, pelvic ligaments of the pelvic girdle should lose by a hormone called relaxin. You remember, relaxin is the hormone released from placenta. Okay, so that one more hormone is there that I am in the, that involve making the involvement of that. Soon after the infant is delivered, the placenta along with decidua, that means endometrium layer, is also expelled out of the uterus. Okay, so finally we end up with the last part of the embryonic development, that is lactation. Lactation means giving milk to the that baby, the mother's milk, production of mother's milk, and in response to the suckling by the newborn as well as changes in estradiol levels after the birth, the hypothalamus signals the anterior pituitary to secrete luteotropic hormone or prolactin, which stimulates the mammary glands to produce the milk. The mammary glands of the female undergo differentiation during pregnancy and starts producing milk towards the end of pregnancy. Okay, that you call lactation. That this helps the mother in feeding the newborn. The milk produced during the initial days, very, very important question, that we call colostrum. The colostrum, which contain IgA antibodies. IgA antibodies. In immunology, we say it as artificial, natural passive acquired immunity. We call it as. Okay, so absolutely essential to the protect newborn baby from the initial sources of infection. After the giving birth, that surrounding that newborn baby may get infections. That's why mother is providing antibodies in that way. Okay, so breastfeeding during the initial period of infant growth is recommended by the doctors for bringing up a healthy baby. That is because of this reason only. That means initial days the mother's milk is called colostrum. It is said to be colostrum. Okay, so the colostrum is containing IgA antibodies. Okay, IgA antibodies. Okay, so that's it about the embryonic development. Okay, during this particular procedure. So from the beginning to the end, it's a complicated process actually. That among them only major events are discussed. That's why during this particular period of time, you may feel so some links are made. So that's why it feels so that is incomplete. Definitely it is incomplete. That means in organogenesis directly we jumped ectoderm, mesoderm, endoderm are developed into directly. Then multiple issues are there. Placenta formation and embryonic development will occur at a time. But we discussed embryonic development first, then after placenta formation. So if you understand these kind of issues, that it is not at all a bigger task for you. So that means put some patience here that to learn this embryonic development.